All right, y'all. As promised, we're going to talk about oxyacetylene welding. Before we talk about oxyacetylene welding, or OAW as the American Welding Society calls it, I first want to just give you the general term, which is oxyfuel welding, because not every fuel that we're going to use or that you will use in industry will be acetylene. Most commonly, it's going to be oxygen and acetylene, but sometimes it may not be. So, oxyfuel welding is a process which involves using a fuel gas and oxygen to heat up a piece of material to weld it together. Flammable gas is oftentimes or is always mixed with pure oxygen. And the purpose of the oxygen within the system is to create a chemical reaction with the fuel gas to generate more heat, to help it combust into a flame. The most common gas is acetylene, and the good thing about doing oxyacetylene welding is most of the time you already have the torch set up in a shop. You may just need to change the tip on the torch, which is relatively cheap because oxyfuel setups are oftentimes used for cutting and heating parts within the shop. So again, oxygen, acetylene tanks, we can do some welding with. I know we talked about this briefly back in Module 3, so just trying to cover a little bit of the basis now as well with welding. You can see down here at the bottom, this image here is an image of somebody doing a cut with oxy acetylene setup. Again, you can change that tip, which you'll see here in a little while, and then you can weld with that setup as well. So why would somebody choose to do oxyacetylene welding? And as you'll see with all these processes, I will discuss the advantages and disadvantages to each so that you can make an informed decision on which one is the best setup for your particular scenario. So, oxyfuel setups or oxyacetylene welding is cheaper and more portable than typical arc welding equipment because it doesn't require electricity, and it typically involves 2 tanks and a set of hoses. Again, it does not require a power supply. It just requires 2 fuel gases. Now, the tanks can be a pain to haul around, but again, electricity is not required. And the big advantage here is that you more than likely already want to have a setup like this in your shop. So you just have to change the tip. Okay. Disadvantages are the weld lines are much rougher than an electric arc welding process. It has a larger heat affected zone. I'll come back to that in just a moment. There are obviously safety issues with an open flame in a shop. Things can catch on fire or be combusted up when using an oxyacetylene setup. And it's a relatively slow process. And I'll add one more disadvantage here is it doesn't work very good on thick materials. Oxyacetylene welding is very relative to TIG welding. And if you know anything about TIG welding, or you will learn about it here in a future video, is it's used for thinner materials. Just doesn't generate. It does generate a lot of heat, but it's very direct where it places it, and so it doesn't do a good job of doing thicker materials. So let's take a real quick a look here at an oxyacetylene weld, and show you the heat affecting zone. So here underneath my dot cam, we can see this weld here that I laid down a number of years ago. And you can really tell here that here's the welding bead itself. This is just a piece of, looks like 20 gauge sheet material. There's your weld bead there in the center. And the blue area on both sides is what we call the heat affected area. The heat affected area, or heat affected zone as some folks may call it, is the area of the material that turns blue. It typically got a lot of secondary heating, which could affect the actual mechanical properties of that piece of material. It can make it more ductile or make it more brittle. It just depends on the type of material. And so trying to reduce that heat affected zone could be beneficial to the process. So TIG welding has a much narrower heat affected zone. Oxyfuel welding is much more broad, and so that is a disadvantage. One last thing I'll show you here is a corner joint using the process. Again, you can see the bead, the heat affected zone, and how do you know it's a good weld? Besides the fact that I did it. Just kidding, is that there's penetration through the back side here. And this is what you also look for with TIG welding. You should see penetration, no holes through the back side here. That indicates a good, strong weld that should last the test of time. Okay? So moving back to our PowerPoint here. Now, hopefully you can understand why oxyfuel welding is good and some of the disadvantages associated with it. This is the one welding process that we will not perform this semester in the shop, but I do want you to be educated about it. So, what type of equipment and safety is required with an oxyacetylene setup? You had to have a tank of oxygen, and you had to have a tank of acetylene. These tanks are pretty commercially available at most hardware stores or like a Tractor Supply or any gas store as well. Easy to pick up, easy to get refilled. These tanks are under high compressed pressure, and so you'll need some regulators. And so there are specialized regulators for both oxygen and acetylene. Make sure you get the correct set of regulators and make sure they're attached to the tanks and that there are no leaks. From the regulators, you had to have a set of hoses. They are red and green in color. The green indicate oxygen. Red indicates fuel gas. In our case, it's acetylene. To make sure they're connected properly and the right color coordination goes together. Acetylene should never exceed 15 psi in any scenario. Acetylene over 15 psi in our hoses can become unstable and hard to manage and could create severe issues. So most of our setups will run acetylene at 5 psi just to be safe, and that's what our torch tips call for. Okay, should never exceed 15 psi. That's the big one. So here's what those regulators look like. They're a little bit more fancy than the ones that you'd find on your grill. Typically, there are two gauges. The one on the right tells us the tank pressure. The one on the left tells us our working pressure. And you'll have a chance to set and work those when you get into the shop. Other than that, you can see the set of tanks there, the hoses, and then the entire welding setup as this gentleman here is welding on. Looks like a piece of sheet material. All right, so in regards to safety, there are a couple of really important things to keep in mind when using an oxyacetylene torch. The scariest thing about an oxyacetylene torch could be the potential for flashback. And flashback is when an explosion occurs following a backfire. So what happens is a backfire, let's define that first, occurs when the tip touches the workpiece. Sometimes the tip will touch the workpiece and stay lit. That's just called a backfire. What happens though is sometimes it will touch the table or the workpiece and the flame will go out or it will appear to go out, and that will be followed by a long or loud whistling noise. If you hear a loud pop followed by a whistling noise, that's called a sustained backfire. When that happens, the flame can sometimes travel back through the tip, through the torch, through the hoses, and then back to the tank. That's when the explosion can happen, or what we call a flashback. If you don't have these cartridges called flashback arresters attached to the torch or to the regulators in one of the other places, then you do not have any protection to keep that flame from traveling back into the gas cylinders and really essentially creating a bomb. So flashback arresters are an incredibly important piece of safety to have in line with the torch in some place within the setup. Typically, we suggest that you put these at the base of the torch so that the flame doesn't even have a chance to go through the hoses and catch those on fire. Okay. So, oxyacetylene welding here. Here's what the flashback arresters look like. They're little cartridges that screw on. Pay attention to the color coding. Pay attention to the arrows. The arrows display which way gas flows through the setup. If they're attached backwards, gas will not be able to flow. All right, I'm going to show you all a video on flashbacks, sustained backfires, and backfires. I think this is incredibly important before you start working with these torches in the shop to understand what these scenarios sound like so that you can recognize them and prevent them from coming into a bigger issue. So let's watch that video now.
Before looking closer at torch handles, we need to explain a few terms and understand some of the hazards associated with oxy-fueled equipment. The terms are reverse flow, flashback, backfire, and sustained backfire. Reverse flow is when either the oxygen enters the fuel gas side of the system or the fuel gas enters the oxygen side of the system. This occurs when there's a restriction of one of the gases or an imbalance of pressure. This can be caused by a clogged or blocked tip, or allowing one of your cylinders to run out of gas. If a reverse flow condition exists, a flashback can occur. Flashback is the return of a flame through the torch into the hose and even into the regulator. It could potentially reach the cylinder. This condition could cause an explosion anywhere within the system. Flashback arresters are designed to prevent the flame from traveling beyond the point of the arrestor. Flashback arresters contain a sintered filter, which prevents a flame from passing through the filter element. Backfire is the return of a flame back into the torch, which produces a popping sound. The flame will either extinguish or reignite at the tip. This is normally the result of accidentally bumping the tip against the workpiece, operating the tip too close to the workpiece, or allowing the tip to become overheated. The last event is a sustained backfire. This is when a backfire occurs and continues burning in the torch. This condition may be accompanied by a popping sound, followed by a continuous whistling or hissing sound. Some of the causes for this are improperly maintained equipment, overheating of the equipment, or improper pressure settings for the equipment being used.
All right, so hopefully you all can identify a flashback or a sustained backfire. Those are really the two most dangerous things there that you have to pay attention to moving forward. So if you pop it and it goes out, just turn it off, relight it, and go again. Just don't sit there and hold it and wonder what's going on. That's the main thing I want you all to gather from that moving forward. All our torches are equipped with flashback arresters. If you assume that a flashback has occurred, it's probably good to change those filters as well. Arresters, excuse me. A few more safety tips associated with oxyacetylene welding. You should use a torch lighter. Okay, I'll show you a picture of one of those in a minute. Never use a cigarette lighter. I know a lot of folks may use those out in the field if they're smoking stuff and they want to light their torches. Problem with a cigarette lighter is it's full of butane fuel. So if the thing catches fire, you basically got it catching fire inside of your hand. Not a good look. It's not going to feel very good neither. So use a torch lighter. It uses a flint. A welding torch with a copper welding tip has a single hole on the end. So your cutting torch has multiple holes. A rosebud tip has a bunch of holes for use. Rosebud torches used for heating up materials. Welding torches and the ones that we use for the brazing operations have one single hole. Typically have a number of 0 through 5 or maybe a little bit higher depending on what you're trying to do. The higher the number, the more heat it generates. You'll need a Shade 5 torch goggle or face shield. This is the same thing we use for plasma cutting. Just protect your eyes. It is bright, but it's not nearly as bright intensity of arc welding. Gloves and welding jacket are recommended, and you need some proper gas detecting snoop. Okay? Snoop is a product that's created that does not contain oil, soap, or any type of component that is flammable for testing oxyfuel setups. So basically you pour it onto the hoses or into the fit where the fittings join up at, and you look for it to bubble. If it bubbles, that means you have a leak. You should never also use a lighter to go and try to find a gas leak as well. I know I've done that sometimes on propane setups. Not a good idea. You should use Snoop. Snoop come up when I first started using Snoop. People told me it was Snoop Dogg sweat. I don't know if I believe that. It's probably got some oil in it too. But however, that is what you should use, and you can find that at most of your local welding stores. Again, it's just a leak detectant like you would for a hole in a tire or something. This is what the torch lighter looks like. You can strike it, and it creates a flame. Basically, there's a little replaceable flint in there that you can replace as it wears out. And here's your welding torch setup. So what we have up there at the top of that picture is the cutting tip. You can loosen that nut there where it says tips are changed here, and you can replace it with a welding tip that looks like this. Most welding tips are 0 or 1. Most of your brazing tips are going to be closer to a 2 to 5 range. But on those torches, it'll tell you what the operation is, what thickness metal you can weld or braze with it, and the pressures that you should use for each of those tips. So that's it for this video. That's kind of more a little bit about oxyacetylene safety. In our next video here, we'll get into the actual combustion zones of oxyacetylene and how we can set it up to do a good weld.